Okay, just a wee video on composite functions. I'm going to start off the video by looking at what is essentially number machines. You actually do number machines way back in level 3. But again, it's to get you the idea of an input, some sort of function, and then an output. So, very basic number machine here. My input, I've got the square root, that's the function, and the output, which is the range, is going to be the answer. So just to give you an example of how that tracks through, if I put in 9, if I take the square root of 9, then I'm going to get 3. Very basic function, and you can see the domain, what we've put in is 9, it's went through the function, and we've got the output, the range as 9, as 3, sorry. Okay, this is a good model to picture in your head when you're dealing with functions. You're putting something in and you're doing something to that and you're getting something out. So if we move the diagram on slightly to a more higher like diagram, like the one below, you'll see that I can do the exact same thing. And these are sometimes called maps, and you talk about the domain mapping to something in the range. If I stick with the exact same function, it's going to be the square root. The only difference being at higher, we're going to define it using more mathematical terms. So my function, which we write down as f of x just means a function of x equals square root of x. So that bit there, very simplistic. This here, the exact same model, but like I said, more in a higher format. And it's the same idea. What we do is we put something in, and this would be the domain, and we get something out, which is the range. So, same example, put 9 in, I would do f of 9, which would be the square root of 9, and I would get 3 out. And that's where the terminology of mapping comes in. So what we're saying there is the input, the domain 9, maps after it goes through the function to the range of 3. Okay, that's a good picture to have in your head, like I said, when we're dealing with functions. You've got something you're putting in, you're putting it through a function, you get something out. Composite functions are exactly what they said in the tin. So if you were in a composite class, that was 2 year groups put together. A composite function is just 2 functions put together. So again, I'm going to take it a wee step back and I'm going to look at the more simplistic number machine model. What I could easily do here is I could add on another step. Okay, so the step that I've added on is just add 3, very simple. So at that point what I'm doing is I am taking my answer to the first output and I'm putting that in to another function. And this function is just very simple, it's just add 3. So my final answer for that one is obviously going to be 3 add 3, which is 6. And again, what I can do is I can model that in a more higher-like fashion. So if I switch down to this one here. So this time what we would describe this as a different function. I'll put this in first, and that's going to be the answer that I get from the input here, and I'll just call that g of x. So g of x is just a different function. Now we can't just write g of x as add 3 because in this context, in this format, that doesn't make sense. What we would say is that's x plus 3. Okay, so again, if I substitute 3 into this function, g of 3, it's going to be 3 add 3, which is going to get me 6. And we now have a composite function. We've actually started off with 9, we've first of all taken the square root, and then we've added on 3 to get a final answer, to get a final input. Now you'll see when I'm doing that in 2 jumps. When we get to higher, what we actually do is we work out the function that takes me straight from the input to the final output. So I don't have to do it in 2 steps, I can just do it in 1 step. And there is a function that will link me from the domain to my final answer. So if we think what we're doing here, first of all what I'm doing is I'm substituting 9 into f of x, get my answer. So far straightforward. Then what I do is I take that answer and I sub it into g of x. So I take what I get from f of x and I sub it into g of x. So if we describe this function as, again, it would be a separate name, it would be called h of x, because obviously again it's going to be different from f of x and g of x. H of x would equal g of f of x. Substituting f into g. That's what's happening here. Taking this function here and putting it into this function and getting my answer. And now what we can actually do is we can generate an expression for the function h of x. Now there's a few key steps here, guys, that I really want to drill, because a lot of kids miss them out and as a result they lose marks. The first step you deal with is very simply just replacing what f of x is with the expression you have for f of x. We know that f of x is the square root of x. So my next line of working is going to be g of the square root of x. And again, that's going to maybe take a wee bit of time of getting used to. But again, it follows the same idea as basic substitution that we've done in the previous two examples with numbers. Now what we do is we replace all the x's in g of x by whatever's inside that bracket. And what is inside that bracket is root x. So my final answer is replacing the x with root x, so replacing the x with what's inside the bracket. And that would be my function for h of x. And I can test this, because if this is correct, if I put 9 into h of x, it should map to 6. So let's see if that's the case. So h of 9 equals, again, all we do is replace the x with what's inside the bracket. Inside the bracket is 9, so it becomes the square root of 9, add on 3. Square root of 9 is 3. 3 add 3 is 6. So we can see that the diagram is backed up by the maths down below. Okay, and I'm just going to talk through one example to finish this up. So the first thing I've got here is I've got two separate functions, okay? They tend to use the letters f and g when they're describing two separate functions, but it doesn't have to be those letters. It can be any letter they want, okay? But it just means a function of x and then a different function of x, hence the reason why they change the letter between f and g. So the first thing I've got to do is find f of g of x. So again, that first step is key. F of, and again, we know now that g of x is 3x minus 4, so I replace g of x with 3x minus 4. That is an instruction that is telling you to substitute in to the function f. And again, all I'm going to do is whatever inside the bracket is going to replace the x's in the function f of x. That's my function there. So that is going to become, and hopefully you can see all I've done there is I've replaced the x with 3x minus 4. So x squared has become 3x minus 4 all squared to equal 1. And obviously what we can do there is we can multiply the bracket. And then we can click like terms to get our final answer. And that's my function f of g of x. The next one is just that in reverse. So in the first one I substitute g into f, the second one I'm going to substitute f into g. So again, let's take our first line of working. Inside the bracket is f of x, replace that with your function for f of x, which is x squared minus 1. So it's going to be g of x squared minus 1. Okay, again, now what we need to do is that's an instruction that's telling us to substitute into the function g. We know that g of x is 3x minus 4, so all I'm going to do, just put this down here, is I'm going to replace the x's in g of x with x squared minus 1. And again, just multiplying out the bracket and collecting like terms to get our final function. Okay, and that would be my function for g of f of x.